Good morning, my YouTube viewers. Crystal here. I just wanted to let you know that I've done some more work on this Ames house prices competition with Kaggle, but I suspect that's the last bit of work I'm going to be able to do unless I overfit the model. What I did was I used a technique called Ensemble that I thought about, where I took 3 of my previous models and I put them all together. And the theory is that you put the 3 models together and the computer will select the best outcome. And that's obviously what happened because of the 3 models that I combined. I got an outcome of 12.913%, which is better than my previous submissions, because when you look at my submissions, my most recent one under the Ensemble notebook was 12.913%, when on Keras was 15.102%, which in theory, because machine learning is supposed to be so super duper fantastic, you would have thought that it would have been a better score, but it wasn't. I actually got a better score with sklearn models. But we keep going through Keras because, obviously I was doing a lot of work on Keras. And on linear regression and gradient boosting, I got 14.017. And at one point that was 13.967. And you can see here, I was doing all this work on Keras, and it wasn't working very well. There was something wrong with the model, so I had to kind of like completely redo it, strip it out and redo it to get it to work better. We did XG regression, which was 13.713, and I believe that was one of my best scores, was XG regression. But as you can see, all of these scores I have just doing the modeling, and I suspect that what people have done is they know the answers. They know what the prices should be, and then they put into their model what the prices should be so they'll get 100% score, which is not what I did, and it's not what you're supposed to do, because then what happens when you do that, you're overfitting your model. So you can see here, 12.913%. It was an improvement on my previous score, and I moved up on the leaderboard. So now I don't know what this 134 means, but I've moved up on the leaderboard. And they have the people who were scoring 0.00044%, which was the top score. And I think that means that they obviously must have gotten one wrong to get the top score. But I'm not sure exactly what I can do to get my score to improve unless I know the answers. I do think that some people have gotten like 11%. Some people have gotten 11%, but I'm not aware of anybody who was doing just standard coding doing any higher than 11%. So what I wanted to do was I wanted to go over this code with you and do a code review so you can see what I did and how I did it. And what I'll do is I'll share this notebook with you, share this notebook with the public. So if you want to look at the notebook, you can. So what I did was I imported all the libraries, and then I imported some more libraries, and it's all in my notebook. Then I imported the files, the train file, the test file, and the sample submission, and the data description. I loaded the data sets so you can see the train file and you can see the test file. So I did info on the train file, and info on the test file. You can see what the train file looks like, and you can see what the test file looks like. And here's a plot of the sales price, so you can see the sales price, the average sales price. And here's a plot of how the overall quality compares with the sales price. So the higher the quality, the higher the price. I checked to see if there were any missing variables, and yes, there are missing variables. And what I did was I declared a variable called all features, and then I combined the train file to the test file. But the train file is missing the sales price. So I defined numeric features. Numeric features are all of the features that do not have a D type of object. And then so I applied a formula to all features to make a root mean squared, to make it a square, so that would standardize the values. And then after I standardized the values, I replaced all null characters with a 0. So we wanted to see if there were any the shape of all features, and it was 2919 and 79 columns. And now what we did was we set up our dummy variables, and what the dummy variables do is they categorize all of the object files. And so we wanted to see the shape of the dummy variables, which is 2919 and columns of 331. So you're looking at your all features. So this tells you what your all features are. And you can see here that when we set up our dummy variables, now all of these text items have been categorized. I wanted to see if there were any null values. And yes, we had null values in the train file and the test file. But what was done was when the object files were categorized, they had a lot of zeros in it anyway. So now you can see your train file, which has not a number. And I had gone through, because you see these not a numbers here. Previously, I had gone through and went at the beginning of the program and tried to make not a numbers and replace it with a 0, and it made my score even worse. So I decided to just leave not a number in there, because it will be taken care of through the fill in A with 0 and the get dummies. So we've got our test file. We wanted to see the shape of the train file and the test file, and you can see it was 1460 by 81 in the train file and 1459 by 80 in the test file. We wanted to see the train info. And here we have a heat map of all of the different columns, and you can see if you can make your way through it, but it's a really complex heat map. So now what we've done is we convert the train and the test file to an array. And then what we do is we reshape the sales price from a -1 to a 1. Now we defined our X, Y, and X test variables. We want to see what Y looks like and want to see what X looks like. And we want to see what X test looks like. And now we use our test train split to split the test training file into a test training and testing. So we wanted to see the shapes of the train X, val X, train Y, and val Y, and you can see that. I wanted to see what train X looked like. And then we've got K-fold in here, which I ended up not using it, and I probably should have taken it out, but I didn't, because I was going to try to put something else in there, and I decided not to because it was too complex, really, for my level of training. But what I did use was I used the Lasso command, and the Lasso module was the very first module that I used to enter this competition. So I put the Lasso module in there, and you can see it's a very simple module when you compare it to XGBoost and Keras, because you had your CLS equals Lasso, CLF fit, train X, train Y, Y predict equals CLF dot predict val X, Y train pred equals CLF predict train X. So that was pretty simple if you compare it to XGBoost and you compare it to Keras. So we wanted to print our R2 scores for our train file and our test file, and we wanted to print our other scores, accuracy scores for our train file and our test file. And you can see that they were pretty good scores. So final labels equal CLF.predict xtest. Xtest is the testing file. Final result is put into a data frame, and then it's put into a file called submission underscore lasso CSV, and it's uploaded, and you can see this is what the file looks like here. And it's called submission lasso CSV. Now what we're going to do is we're going to do linear regression, and linear regression and gradient boost was a module, one of the modules that I had used to improve my score. So regression equals linear regression, reg fit equals train X, train Y, reg score equals val X, val Y, and that was a good score of 86%. Then we did our gradient boosting regressor. So, and then we fit it, and then we scored it, and we had a score of 90%. So that was a good score. And it was an Ensemble as well. So what they did was they took two modules and put them on top of each other to try to improve the score. YPRED was reg.predict xtest, YPRED, and then you got your CLF predict xtest, and then you got your final labels and your final result, and it was made into a submission reg score. So in this particular instance, they took two models and they put those two models on top of each other to try to get a good overall score. So there's lots of things that you can do to improve your scores. It's quite complex, really. It's a lot of study. And then the last model I used was my Keras model, and my Keras model was the most recent submission to Kaggle, but I decided to go ahead and use this Keras model as well because it wasn't too difficult. So we set up our sequential model. We fit the model, and so when we fit the model, it did its training. And you can see everything that it has done. And then what we did is we plotted our losses. We plotted a summary of the model. And then we made our predictions based on val X. So that's the actual training file that we predicted on. And then after we made our predictions, we predicted on the test set. That was the testing file. So we flattened the prediction, because you have to flatten the file to get it to work. And when you flatten it, you changed it from 2 dimensions to 1 dimension. We put our final labels into a data frame, and we submitted that, and we called that submission keras.csv. So you can see the submission keras.csv. And then now what we're doing is we're averaging our 3 submissions. So submission average equals submission Lasso plus submission reg plus submission keras divided by 3. And then if I had another model to use, then I would have put that other model in there and divided that by 4. So you can see your submission average here. So what we did is we put all of our submissions into a data frame. So my submission equals PD data frame. My submission ID equals DF test ID. My submission sell price equals submission AVG sell price. My submission to CSV equals my submission CSV. And I uploaded my submission, and here's my submission. And that was an average of the 3 models, the 3 submissions, which is another way that you can put models on top of each other and then get the average to come up with an outcome. And the theory is that if you take 3 models and put them together, then the computer is going to select the best value. And that's exactly what it is. So we did 2 things in this model, in this computer program. First thing we did was we took the gradient boosting and combined that with linear regression to get a better score. That was the first thing we did. And then the second thing we did, we took the 3 models and we combined those 3 models to come up with a better score. And we did get a better score. We got a score of 12.913%, and that's my best score to date. I don't know what I'm going to do to get a better score, but I'll just keep working on it. If I come up with any new methods, then I'll definitely endeavor to improve my score. But I'm not sure exactly how I can do it unless I knew the answers, and then you're not supposed to do that because that's overfitting. So that concludes my presentation on the Ames house prices and the Ensemble way to get a good score. If you like my program or my presentation, please like, subscribe, and share. If you like the work I do and you want to make a donation, I've got my email address for my PayPal account down below, because I don't have enough subscribers, so I can't get monetized. The only way I can make money off my site is to ask for donations. And thank you so much for watching my video. I hope you get some benefit out of it, and I look forward to making the next video for you.